Okay, in this lecture we're going to talk about small samples, and these are samples which are of size n less than 30 where we can't use the central limit theorem, but we can under certain conditions use something called the t-distribution. And so let's sort of get started here. Our motivational exercise. Professor U.N. Repeatable is making a study of Sasquatch livers. He desires to get an estimate with a 95% level of confidence the weight of such livers. However, obtaining samples is difficult, as this is not an organ Sasquatch'll part with lightly. Lives of grad students have been lost along with equipment. Is there a solution? Okay, we can proceed with small samples under the constraint we assume the original random variable is normally distributed. The original random variable is normally distributed, and in such cases we can calculate the margin of error using the following formula. Okay, and so let's look at E is equal to, okay, t sub n minus 1 comma alpha over 2, oh my god, times sigma over the square root of n. Now this is the same general form as the margin of error for the regular, only we have this for our fiddle factor. We have this t value instead of the z value we had before. I've got along with the alpha over 2, I've got this n minus 1. This n minus 1 is called the degree of freedom, and you know when you know your sample size, you know it. So usually we suppress it when we write it down to make a cleaner formula, and use this formula in the box below, where the only difference between it and our regular margin of error formula is we have a t instead of a z. Okay, and so if you know how to do confidence intervals regularly, you know how to do this. It's just in getting the t instead of the z where the difference is. So, Professor Repeatable's grad student obtained 5 livers weighing, okay, 5.4, 4.2, 5.6, 3.2, and 5.7 kilograms. Okay. Well, okay. So what do we do here? Well, we have a sample size of 5. This gives us, okay, our degrees of freedom. df is equal to n minus 1. So 5 minus 1 is 4. Okay, I hope I'm not going too fast for you. Okay, we take those 5 values and we average them. We take those 5 values and we do the sample standard deviation for them. It's a 95% confidence interval. That means alpha is 0.05. We take alpha over 2 at 0.025. We then do a table lookup, which I will show you how to do, and that gives us 2.776, and we then take these numbers and follow the arrows, feed the formula, just boogity boogity boogity, crunch it through, and you round off your answer to the same number of decimal places you have in your x bar and in your s. And remember, both of those are 1 decimal place beyond the original data. Okay, and so our estimate x bar, okay, is 4.62, which we know is almost certainly wrong. It could be too little, so you add the margin of error and get 5.82. It could be too small, so you subtract the margin of error and get 3.42, And this is all done with 95% confidence. Okay. How do you find that t-value? Okay, well, start off with your sample size. You get your degrees of freedom by subtracting 1. Gives you 4. Okay. The 4 is the row, right, that you look it up on. Okay. The 0.025, that's the column you look it up in, and so where the row meets the column is the number, the t-value. Okay. Parents cleaning the room of their college-age daughter find the bodies of 4 Norwegian rats among the soda cans and candy wrappers. These rats have the following weights: 7.2, 4.5, 8.4, and 3.5 kilograms. Okay. Again, this is very funny if you know the metric system. Determine a 90% confidence interval for the rats that inhabit her room. Okay. So you have 5 rats, you subtract, 4 rats, you subtract 1 to get the degrees of freedom, 3 degrees of freedom. You take the average, right? You take the sample standard deviation. 90% confidence gives us alpha equal to 0.1. Alpha over 2 is 0.5. You go to the third row under the column with a 0.05. This gives you 0.2353. Then you feed the formula, right? Your standard error of the mean times your fiddle factor gives you this 2.82, again rounding off to 2 decimal places because your original original data was at 1 decimal place. We have the estimate, okay, which is x bar is estimate, almost certainly wrong. Add a little, okay, add your margin of error, 8.6, subtract your margin of error, 2.56. So this is somewhere between 3 kilograms and 8.5 kilograms. You know, that's a part of a wide thing, but it does give you some idea, some range to deal with. But 90% confidence. Okay, Johnny come lately. The new man in quality control samples 12 16-ounce bottles produced by a particular filling machine. The sample has a mean of 16.1 ounces with a standard deviation of 0.3 ounces. Determine a 98% confidence interval. Okay. So sample size of 12, degrees of freedom 11. Okay, 98 confidence gives you alpha equal 0.2. Alpha over 2 is 0.1. So you go to the 11th row and the 0.01 column. Your fiddle factor, your t-value is this, 2.718. So you take this fiddle factor times your standard error of the mean. This gives you a error of 0.2. Okay, margin of error 0.2. Our estimate was 16.1 plus or minus 2, which rolls out to a confidence interval. Mu is between 15.9 and 16.3 with 98% confidence. Okay, so this stuff is going to be calculator intensive. You need to obtain a calculator if you've not done so far. Quite frankly, I don't know what the heck you've been doing if you haven't gotten a calculator at this point. And you need to use this to calculate the means and the standard deviation. And let me tell you, the standard deviation has sold more calculators than the space program. Seriously. Take out your pencil and paper now, and here's a set of numbers. Do a practice set. I'm going to, while we sit here, I'm going to just run through the numbers. I have a calculator. The first thing you're going to need to do is clear your stat registers. Make sure it's empty. Then you enter the numbers. 12, 15, 14, 15 again, 14, and 16. And if you have a calculator like mine, it counts the numbers as you go along, so you don't lose count of them yourself. But when you have numbers that repeat, this is in particular a problem. I press the button on mine, which gives me the average. Second key in X bar. This will give me a mean of 14.3, right, rounding off. Okay. The standard deviation, I find on mine it's marked with a sigma x n minus 1 on it. Press the yellow to get to it, and this is 1. It's 1.36. I'm going to round it off to 1.4. Okay? So you run through this yourself to see if you can reproduce these results. Practice set 2. Okay, clear out my stat registers again. And I go 7, 8, 9. 7, 8, 9. Sigma plus, and then 6, 5, 4, and 5, 6, 4, and 8, 9, 7, and 4, 5, 6, and 4, 5, 4, and 7, 8, 8. Okay, this time 7 numbers, and I get a mean of 657.4 rounded off, and a standard deviation of 174.38, but it'll be 0.4. Okay.